Let's talk briefly about cable, DSL, and fiber optic internet services. These are three of the most commonly used internet services in the United States and in a lot of other areas around the world. Cable internet access, also known as broadband cable, uses the same cable lines as cable television, but it sends and receives information over different channels. So you have your regular TV that you watch, and you're changing channels with your remote control, which really just changes the frequency that it's grabbing information from off the cable line. But your data through your internet connection is sent on other channels, other frequencies, but on the same line. Data download rates range from 5 to 50 megabits per second, and upload rates are a fraction of that. So, for example, my connection is typically 25 megabits per second down and 4 megabits per second up. But that's going to vary. There's a lot of possibilities with that. Like most internet connectivity options, cable internet is shared by the customer base. So, the more users that are on the internet, the slower it becomes for everyone. And I like to test the speed of internet connections and get an idea of how that speed works. One place I'll go is DSL reports and go to the speed test and then select the type of connection, in this case, cable. That'll run through the test and it'll check latency against servers in the area and farther away. So, for example, I'm in the New York City area, and you can see here we have 25 milliseconds is the latency for a server in New York, and it gets higher as the geographic location of the server gets farther away. And you can see here it's doing the test. It completed the download test. It sends a bunch of data and takes the average of that amount of data, and it takes the average, and we have about 25 megabits down, and we're hovering around 4 or 5 megabits up. So just about what I was saying is what I'm getting. And usually providers will cap you at some certain amount. So, check out your speed test. And if it's, really low and you're using fiber or cable or DSL and you think it should be higher, this is a good way to tell because it's sending a lot of data back and forth over the internet. And check your latency also. Sometimes you just need a new patch cable or a better wireless network adapter, or maybe even a new router, or possibly a new cable modem. The cable modems use the DOCSIS, and you want to use the latest DOCSIS standard so you can get the highest speeds, basically. The cable internet connections uses RG6 coaxial cable, and it uses a screw-on F connector as shown here. So here we have a cable modem and a cable for it. And if we look at this typical cable modem, we see we have the screw-on connector here. That's for the F connector. And we have our RJ45 connector to go out to a desktop computer or laptop or to a router, and our power connection. And if you look here at the connector, this is a typical screw-on connector, and it screws on to the terminal here. So that's your standard F connector, which is crimped onto an RG6 coaxial cable. So this guy connects, and we screw it in. And you want to make sure that you screw it in as far as you can, because you want to get good connectivity between the copper conductor and the port here. So sometimes you might need a little pair of pliers to make it a little tighter. So you want to make sure that connection is tight. That's one of the things you want to troubleshoot when checking a cable internet connection. Sometimes this is just loose, or the patch cable, this coax patch cable that leads to the jack on the wall might need to be replaced, or one of the ends might need to be recrimped. If you look here, you'll see that the copper wire comes out a little bit further than the screw-on connector, and that's what we want. We want that copper wire to stick out a little bit so we can get good connectivity to the port. So that's a typical cable modem, RG6 cable, and F connector. And it's good to know the path that the data will take, the path from the ISP, basically, the internet service provider. It's going to go through the data communication lines, which could be coax all the way, or it could be fiber optic lines, depending on your distance from the central office, from your provider. So it could be fiber for a long run. Then when it gets to your neighborhood or to your office area, it'll become coax, and then RG6 cable to the home or office, and that'll go to either a network interface device or to the cable modem, and then to the Soho router or to the individual computer with that RJ45 connection. So that's basically a little bit about cable internet access. On to DSL. The digital subscriber line, or DSL, provides digital data transmissions over regular phone lines or specially cabled connections, and that depends on which type of DSL you get installed. There's two types that you need to know for the exam, and that's asymmetric versus symmetric. Asymmetric means that the download and the upload rates are different. Symmetric means that both of those rates will be the same. They'll be the same number. So you have ADSL, asymmetric digital subscriber line, and this enables transmission over copper wires, usually the same phone line that you'll find, the POTS phone line that you'll find in a home or an office, but it's way faster than the old school dial-up connections, and it's digital. It's generally geared toward the consumer that requires more downstream bandwidth than upstream. And you can see here the download rates range from 8 to 52 megabits per second, depending on the version. And upload rates, they're going to be a fraction of that. Maybe 1 megabit per second upload. So there's a whole group of ADSL technologies. But the idea behind this is that you're normally using the phone line that's found in many homes and offices, and also that it's asymmetric. The download speed is much faster, and the upload speed is going to be slower. It's going to be a fraction of that. The other one is SDSL, or symmetric DSL, and this is usually installed usually to companies as a separate line, and it's more expensive, but it has less latency. It's a more solid connection, and the upload and download rates are the same, anywhere from 1.5 to 5 megabits per second or thereabouts, depending on the version. But you can pretty much be guaranteed that you're going to get a solid connection with SDSL. And a typical DSL connection, that ADSL connection, that'll make use of the RJ11 jack, your phone line in an office or home, and therefore it's running over twisted pair cable. And it may use a DSL filter or a DSL modem. And I'll show an example of a DSL filter here. So here we have a typical DSL filter, and if an organization or a home office uses a DSL line, they're going to use some type of DSL modem, most likely with the PPPoE protocol. That's going to share the phone line. And so any actual phones that they want to use need to have a DSL filter. Now, normally you would connect the phone, if it's a landline, with your typical RJ11 connector and cable. But if you have that DSL running on the network and you're sharing the phone line with the DSL data, then you're going to need one of these filters in between that phone line. And so we'd need to plug the phone into the line into this filter, and then the filter goes into the RJ11 jack on the wall. So if you ever see one of these, you know that either the organization is running DSL or they used to run DSL, and this filters out the DSL data that would normally come through the line, and it's because that's being sent from the provider. And so this will filter out the data that's coming through the line and just allow those phone conversations. And so remember, DSL is the way of getting around your dial-up line and getting a faster digital connection on that. Know the differences between asymmetric and symmetric, and know that you might be able to use DSL with the regular phone jack, but you're going to need a DSL device. You're going to need some type of device to make that data connection.
When it comes to the fastest speeds on the internet, right now you can't beat fiber optic. It's so much faster than, say, cable internet or DSL. It'll really amaze you when you see the speeds that some of these companies are achieving. So if you really need a high-speed connection for your organization or even at home, think about fiber optic internet. Let's talk about that a little bit more now.
So, fiber optic internet access uses passive optical network technology to transmit data via photons. It's using light to send information over the glass, over the fiber optics. It's passive, there's no electricity needed, there's no copper. The data download rates are going to be way faster than your typical broadband, cable, or DSL, and it's going to range from 100 to 1,000 megabits per second. Upload rates will be a fraction of that, between 20 to 200 megabits per second, still very fast. And this will all vary with the service, who is your provider, and the technology they're using, and also how many people are on the internet. For example, a user might have Verizon Fios, which has a typical download rate of 600 megabits per second or thereabout as a maximum, and a typical maximum upstream of 150 or so megabits per second. You're never going to get to that maximum, but that's the stated maximum. This is going to be 10 times more, 15 times more than your normal maximum rates on cable. And there's other services out there like Google Fiber that can go actually faster than that. But it all comes down to the network infrastructure. At the central office of your provider, they have switches. And it all depends on how powerful those switches are, how fast they are, and how many ports they have available. Really, the more ports is going to be worse. If you have more ports and more users, that's going to clog up the network more. So the more users on the connection at the same time, the slower it's going to get for everybody. And the age of the switches and the speed of the switches is what you're really interested in with that network infrastructure. Some providers will give you that information. Some are pretty hush-hush about it as far as what they have in that network infrastructure. But that's what really matters here. What switches are being used, what routers are being used, and how many people are connecting at the same time. So it's all about that central office. And the path that the data takes from your internet service provider, whoever the fiber optic provider is, will go through an optical line terminal at their office. And from there, it's going to go through a single mode optical fiber to your neighborhood or to your office's area. So single mode fiber, and it's going to be a high speed data throughput, extremely high speed, even faster than what you're going to get at your connection. And so that single mode fiber can go, multiple kilometers, gets to the neighborhood or to your office, then to the passive optical splitter in your area. And that's going to split the signal to multiple customers. And then from there, that'll go to the individual customer's optical network terminal, which is basically the network interface device. And at that point, it becomes a hybrid network because it then changes over to copper. And it's either going to be coax or it's going to be twisted pair at that point. And then it gets to your Soho router or your individual computer or what have you. So at the home or the office, this copper connection could use a twisted pair patch cable, for example, Cat6. That's very common. And then that'll go to your Soho router or to your computer. Or it could use a coax cable using the MoCA protocol for high-speed transmission, because normally on coax, you can't really go that fast. But using special protocols, you can compress the data over coax and send the information very quickly. The twisted pair is going to be preferable because that works better with high-speed protocols than coax does. But either way, at that network interface device, that optical network terminal, that's where it changes over. You've got the fiber connection coming in, and then your coax run to your Soho router or what have you. And that optical network terminal will either be inside your basement, or they might attach it to the side of your house, or in the office, it'll be in the server room or in the wiring closet. And typical examples include Verizon Fios and also Google Fiber. And in some areas of the United States, people are getting connections, actual tested connections with Google Fiber at like 6, 7, 800 megabit per second downloads. So, if you compare that to my 30 megabit per second connection on cable, that's a big, big difference. And that could help me out a lot, but there's no fiber in my area right now. That'll change as time goes on. More and more people will get access to fiber. It's very expensive to install the infrastructure and to run the lines, especially that single mode optical fiber. It's a big deal to run those. So, that'll take time, but over time, more people get access to it and the speed will increase. Fiber can go incredibly fast. So I wouldn't be surprised in 5, 10 years, you have 10 gigabit connections. Let's wrap up the three. You have your cable, your DSL, and your fiber optic comparison here. Remember that cable and DSL are both copper-based services, and the cable is going to use RG6 coaxial to the customer's cable modem. DSL will typically use twisted pair, but both of those are going to max out at about 50 megabits per second, regardless of, it's going to be different from one service to the next, but generally you're maxed out at about 50 megabits per second, whereas fiber optic can be as much as 20 times faster than that. And fiber optic uses glass. It uses light to send the data. So a little comparison of the three right there. And that's about it for this sub lesson.